Hello, everybody. So today we're going to talk about this little project that I have been doing, which is using Google's AIY kit to do some interesting stuff. So I guess the first one I'm going to talk about today is the Google AIY Vision Kit. So what that basically is a Pi Zero connected with the Pi camera, and Google had a sort of kit to build in a cardboard box where they put all this stuff sort of together, and then you can record images. The interesting thing is that they also have a extra board in their kit, which does some of the image recognition stuff. So that's interesting. You have onboard image recognition. Now you don't have to go to any cloud service or even your own server to make an image classification. So that's interesting. And the particular kind of functionality I'm gonna demonstrate today is their facial recognition model. So on their onboard chip, they have I would say, relatively smaller model that recognize if it see a face in the camera. So how this can be interesting, and that's kind of what I use for, is that um, for I would say, a monitoring system, or maybe a system you just want to know what kind of stuff is a camera seeing, right? You want to have a first gate of saying, oh, did I see something interesting? Otherwise, you'll be taking images throughout the day, uh, and you're going to have to do classification of all of the images. So that's a problem in terms of two things. One is there's just too much data that way. If you have to go through all of it, right? It just computing power, all the resources, it's boxed down your system. The other thing is, if you don't know what it's seeing, it's very hard to do much of the later analysis. If you know there's a head, in the picture, then you have some kind of idea that's interesting. So that's a good filtering first system. And what I kind of use is use that part and say, oh, I see something that could be interesting in my pictures, and I want to go further analyze that. Today, I'm just going to show you the first step of doing that, which is pretty much using the facial recognition stuff on board. So let's go through the first thing, which is where do you get that kit, how does that work, all that kind of stuff. So on this landing page for Google AIY, you can find they have the vision kit is on the left. I'll go into that in a later video. But the one I'm using right now, it's on the right. So let's go scroll down to the vision kit. Let's click on build it. They have more instructions there. So a couple other things. I got mine from Adafruit, which is, I think their headquarters is in New York, which I bought it there because I felt their mission statement, which is helping sort of younger kids learn how to do this kind of stuff, which is great, and also they're actually relatively convenient in the United States anyway to purchase. So I went and got it from there. Sometimes they don't have all in stock, but it's a short wait anyway. So let's go look at the Vision Kit. It's come up in exactly this little box, and when you open it up, make sure it's actually the version 1.1, which is what the Adafruit company have. So once you open it up, you basically see all this components in there. I would say it's fairly easy, just follow the instructions. There's a couple of things which it was a little hard for me anyway, because I'm a new sort of in this DIY space. But when you put the boards together, specifically these two boards and these two things, This little stub thing that connects these two boards, to me anyway, they're a little bit tough to push in. Uh, maybe I have weak hands, whatever. But it was a little tight to put it in. But I can understand why they did it that way, right? They want to make sure it's super secure, especially if you have a cardboard box, which it's kind of stiff, but not the most I would say the most sound framing structure. I might go into later videos on using Amazon's Deep Lens, which I see it's a more complete package than this. But obviously, you kind of have to deal with the sort of Amazon AWS stuff. Or it's not required, but easier to do it that way. So I might go into later video talk about how to use Deep Lens to do all that stuff. But like I said, it's relatively easy. Just make sure you connect the camera to it. So it's most of the time it looks great. So once you follow all this instruction to make it work, it's really easy. Let me scroll down all this stuff. When you get to after you install all this kit, you go on to the say try it out part. Oh, yep, this part. Once you turn it on, right, it gave you instructions. It come with a smell or joy detector, um, which will basically have the image taken, look at whoever's facing it, and see if they have a smile. So that's a smile or no smile model, basically. So it's all well and interesting. It's not that much you can do about that. um, so we'll move on to the interesting stuff that I think was interesting anyway. First thing, you do have to stop their face sort of joy detector app. They made it so it run from startup. So you have to do it from that, which is, let me see, they have instruction right there. Okay, so you do have, this is instructions of how to stop the demo. And also if you want to stop it from running in the at the startup, that's what you run. But I actually found that to be, I have to yet to figure out exactly how that works with apps or services on startup. But this actually didn't work for me. So if anybody have a reason why it didn't work for me, let me know. Okay, so I kind of started to build my own app, and the ones they supply is called face detection camera. So I basically just adopted that code from their sort of GitHub page. And they give examples how to use both the vision kit and the voice kit. So that's great. I kind of just adopted their code. Um, so if you're looking for anything that you want to sort of use, feel free to just go around with that. It's mostly great, it's Google code. It's fairly easy to read. So that's great. But what I'm going to do over here is just to walk through how I used it to basically detect a face, and then so using the camera, have the camera running at pretty much all times. Take a picture once. Um, uh, let's say they set it at 30 frames per second, but it's actually running slower. I find to be actually around 15 frames per second. So for those frames, take a picture, go to the onboard face detection model, and if I found a face, then I would transfer that image to my own server, and then I would save that as that's something interesting. I see a face during the day, maybe. Um, I believe the camera does have some abilities to detect low light conditions, since it's actually work with infrared. But this kit doesn't come with infrared, obviously. So if that's something interesting, you have to dig around more on that issue. But okay, so that's go into the code and see what's happening. So I'm kind of I guess, sort of not a exactly object oriented, kind of developer. I'm more using functions, but from here, there's a lot of things that you have to do to make the camera work. So I found that just using their uh, object that they designed, it's the best way to get it to work. So anyway, so I started the face detection object and then started the recording stream. So what that does, let's go in here. You have to first set make sure you're using the camera. So you're streaming uh, images using camera object using the, I guess, Pi camera that they linked it to. There's a instruction there for what kind of sensors, what kind of resolution that you can make. I basically just choose the maximum resolution there is. And if you notice here, I'm kind of getting some values from a uh, Redis server. So I kind of have that Redis server stand up sort of right now, just only for this, but it's very good in terms of that. If you want to change stuff on the fly, that's very useful. Or if you feel whatever you like to do, just have configuration files that also works fine. But anyway, so in this camera, you set the resolution to be this maximum resolution. And essentially, I set the frame rate to be 30, which is the maximum it can do. Right. And then the other thing you have to kind of worry about is the shutter speed. And obviously, I'm not a camera guy. I don't know that much about how it works. But I essentially just set this to be the as fast I can do it because so in general, if it's faster, that means you're a strong light condition, right? If it's too slow, then it will expose for too long, and your picture are going to be overexposed. And if you use overexposed pictures to train your training data, it's going to be, obviously looks different. And the rule is basically if you can't tell from a human looking at the picture, there's no way a computer algorithm can do anything for you. So set to be the mode to be the sports mode, which is also the fastest, dealing with sort of like a lot of light, that kind of conditions, and you want to make sure in those conditions that you capture um, the person while it's moving, right? So, all right, so my bad. I just remember why I set it to be the sort of the fastest is shutter speed, right? Because I don't move that fast, but I find if you set it to be kind of slow, your picture is blurry, right? Then if you have a blurry picture, you can't tell who is it or whether even it is a person with a face. So that's why I set it to be fast, but in low light conditions, obviously you might want to set it to be lower, I think to a certain extent. Obviously it doesn't deal with when the light is too low, but I haven't tested yet. So that's the idea. And then you got to set the camera interface right there. And what I said here is going to the facial detector mode. So what this does, it kind of goes to the sort of onboard chip for some kind of machine learning model inference, right? Yet to be learned how to do that, but anyway, so what it does is when this is running, I can send this. Let me see. I can send the picture over to this inference, and I got a result whether I can detect a face or not. So what I did there is, if I see a face or the numbered faces on my from the result is at least one, right? And I would say, capture that frame, and it's all good. So let's look at how that capture frame works, sort of, right? So for here, once I detect a frame, I send that the camera object to this function. And for here, I'm looking at a couple of different things, right? I also don't want to make sure I don't have too much data flowing in. So this is the time lapse interval. So this is like the time between the last time I took interest or find a face in that. Um, you can feel free to change that parameter to anything you like. Maybe you just want to take picture all the time and see what's happening. But I kind of in here I kind of thinking about the issue. If I do this too many times, I might get too much data. But it ended up being not that many. It's well, compared to the other project, which is the voice project, which I continuously recording voice data, uncompressed voice data on top of that. So that's a lot of data, even for the what I found was interesting. But anyway, I'll go into a separate video on that. But here I set it to be 1 minute. So I'm going to take another picture only if it's after that 1 minute last time I took a picture. So if I find that to be the correct amount of time after I took the last picture, then I would record the date time format, and then take a picture, or actually capture the picture into a file and save that locally. But then what I did after that is I actually have a sort of file storage server on my own. So I want to keep all my files all in one place, and so that I can use for later pre-processing. The idea is being obviously this Pi camera or the Vision Kit, it's just a Pi 0, so it has limited amount of resource, and I want to use it as a sort of peripheral device, right? I don't want to use that for central processing. So kind of just like, if you can think of it like, I want to think this as my eye, right? I don't do any processing at my eye. I just take the picture and send it to my brain. So if you think about that way, what I did is created, sort of a new thread. So I don't interrupt with my ongoing process of seeing pictures. And then I'm using a secure FTP sort of protocol to send that picture to my own server for processing. So that's what I did there. It's fairly simple. Just let me see. Maybe we'll take a look at that saving functions. So let's go to the util function. Anyway, just walk some stuff. The Redis server there. I have my local. Hopefully you won't figure out my IP address. But anyway, if Redis server there I'm connecting to. So save the server, right? So that's also fairly simple, I would say, just to make sure you kind of know what I'm doing. So I'm basically loading the server info, which is username, passwords, all that stuff to go into my server. Probably should set that to be some kind of key or even RSA tokens to do it. But that's right now. I just have username, password, and then I'm using a secure connection that goes to my own server within my own network. And then once I save it, just it's all good. So the only other thing I want to point out is so I'm using the thread there to at least make sure I don't have interruptions. So that's basically the idea. So once I get all this set up, what it does is I need to go onto my SSH into my the Vision Kit, the Pi Zero operating system, and then I would use TMUX to start a um, uh, the face detection camera program. Just remember that you need to actually use Python 3 instead of Python, since they do have Python 2.7 on there. Um, that took me a little while to figure out. But anyway, once you start that, this loop, if you noticed, uh, where was it? Yeah, so this is basically a loop that just keeps going. So once I stop, so you have to use Control C to stop that one. But anyway, just keep going. And what it does is take a picture when onboard facial recognition sort of model says, I see a face. And then I take a picture of that, send it to my own server and use that for later processing. So that's kind of all the stuff I did. I just felt kind of want to share this in case anybody like to see how it works with a Pi camera. I thought it's pretty interesting project to work on. Uh, there are also other models on the Vision Kit sort of onboard detection. You can sort of do, I think they have the ImageNet sort of data set which you can detect different kind of objects. I also try to do a different thing, which maybe I'll show it here. Yeah, so I'll show it anyway. So in the Google Vision, they also have a cloud service. So Google Vision have a cloud service where uh, they can have this image annotation annotator client, which I thought was pretty great. What that does is will detect a picture, detect sort of objects on the picture, and send back all the objects that you see in a picture. So that could be interesting. It does need a little bit of handling there because they send you back a protobuf object instead of a um, JSON. So you have to do a little bit of converting result. But anyway, they give you a bounding box. Maybe that's so. You know what? Let's go look at what they have. Go take a look. There you go. It's the cloud service. Should have done this better, but essentially they just have ooh, do they have a right there? Nope. I gotta do this better next time. But anyway, so what it does, it's a draw a bounding box and send back all this vertex, coordinates of the bounding box and the object it detected. So you can, if you want to do it that way, that's also something you could do. Their service obviously does cost money, but if you don't do it frequently, they give you a certain amount of quota. I think maybe some number of pictures that you can use per month. So if you want to use that way, that's also another option. But anything, I'll wrap it up there. So you can kind of use this AIY kit from Google to detect pictures and send it for central processing. And I walked through some code you have. If there's anything you like, comment below. I'll see if I can answer questions. But see you next time. Thanks, everybody.